Hello everyone, welcome back to my channel again, General Technology Knowledge. Yes, today I would like to show and share about how to create the function block of the PLC S7-200 CPU 224 HP for testing with the real PLC. Okay, so first I would like to explain the concept of how we use the analog output for scaling. Yes, this is an example that I draft for easy to understand. Example, operator have the type panel, so they can press this one set point value from 0 to 100% to the PLC CPU 224 HP, and then the PLC will generate the analog output from 0 to 20 milliamp or 4 to 20 milliamp to control the VSD, and then VSD control to the motor. Okay, this is a concept. That's why we create the function block for control the VSD by using PLC S7-200 CPU 224 XP. Okay, so to create this block, let's go to the software step 7 microbit. Okay, so first open the software step 7 microbit. Yes, inside the blocks we need to create the 3 input, right? One for set point input from operator linked to the PLC via a type panel, and then the second create the high scale, the third create the low scale, and the last one for the output for control the VSD. So we need 3 inputs and 1 output. Okay, so let's start. To create the function block, first go to this tab, and we can rename this tab. Example, AQ or AO scale. Okay, analog output scale. So we need 3 input, right? So one for the set point, right? Set point. Data type we need to the real value. Okay, so this is the input. The second is the low scale, right, or high scale. Data type right real also, and another one low value, low scale. Data type real also. Okay, so this is the input we already create, and the last one is the output. We can say output. Data type real also. Okay, so we need to create the formula for generate from 0 to 100%, and then output analog output 0 to 20 milliamp. Okay, so let's start. First I create the always on for the block. SM0.0, and then I choose the sub real. Okay, so this one I choose the set point from this one. Okay, the variable that we already created, and the second is the low scale, so we can see low scale, and we must create the variable for temp for auxiliary this one block. Okay, so I will choose the out sub real, and the data type is real also, so this one is the out sub real. Okay, and another block we must choose the multiply the real. Okay, multiply real, and I will copy this one and paste this one, and this one is the maximum of the raw value that generate to 20 milliamp, so we can press F1 to get here, and then search the data type. Okay, so the max raw value is like this, so we can copy and then paste here, Ctrl V, and then enter. But we must have dot zero also, because it's the real value, so I need to create one more temp. So out real, and data type is real also, so this one is out real. Okay, and one more block for sub real, for subtract the high value, high scale and low scale, so I choose sub real. So this one is the sub between high value, high scale, and then low scale, so high scale and low scale, and then I need to create one more temp for low scale, out sub high low. Okay, and the data type is real also, so this one is the out sub HL. Okay, it means that high value subtract the low value. Okay, and then I need to divide this one with this one. Okay, so I need mount divide real, divide real. Okay, so I need this one, copy and then paste and divide by this one. Okay, and then we will got the output. Okay, so output. Okay, so that's all for the formula for convert, and then we will call this block to use. Okay, with the main block. So first I need to call this block first. Okay, I will drag and drop this block to this main program, and then I will choose the always on. okay, SM0.0, and for this one I can choose the memory, another memory. Example for operator, example MD0 for real memory, and this one VD0, this one VD4, and output example VDH. Okay, and then I will convert this real value to double integer, so I need to use the converter, and then choose this one. Yeah, for convert from real value to double integer. Okay, so like this. So this one, copy from this to this, and move this one to the VD12 example. So this one we must convert from double integer to integer, right? Okay, so I choose the converter and move from double integer to integer. Okay, so this one is the VD, so we can copy VD12 and then convert to analog output. So AQW1, sorry, 0. Okay, so that's all for create the program for function block for control the output. Okay, so right now we must download this our logic to PLC. So to download, first click communication, then check the communication. I will connect this one to PLC first. Connector to PLC, okay, and communication again. Okay, and then download to the PLC. Stop the CPU. Okay, start the CPU and online to check. Okay, so we need to have the scale, right? High scale and low scale and set point also. Okay, for example, the high scale is the 100% example, so 100.0, and low scale I want to start from 0, and right now the PLC is so sorry, the multimeter is so 0 milliamp. Okay, so 0 milliamp. Example operator set to, okay, so 0 milliamp. Example operator set to 25%. Yes, the milliamp is changed. 25%. From 0 to 5. Yes, something. The milliamp is changed. Example, okay, from 0 to 5 to something. 100%. Example they set to 100%. 20 milliamp to it will provide 20 milliamp to multimeter or to the VSD. Okay, so this is a concept about how to create the function block for analog output of PLC S7-200. CPU 224 XP. Okay, so thank you very much for watching my video, and don't forget like, comment and subscribe my video also, and I will create new video for everyone also. Okay, so in this time I would like to say thank you again and see you next video. Bye bye.